So first, let's briefly explain what sound and digital audio are. Sound is a vibration of air. Here, air is a medium for transmitting vibrations, and sound cannot be heard in a vacuum without a medium. These air vibrations are transmitted to the eardrum and along the nerves to the brain, where we perceive them. On the other hand, when sound is input through a microphone, air vibrations are converted into electrical signals, which must be converted into numeric representation in order to input them into the computer. The device that performs this digital conversion is called an analog-to-digital converter, or ADC. Sound is a longitudinal wave, causing the air to vibrate back and forth. If you look at the picture above, the parts with high density of air are expressed darkly, and the parts with low density are expressed lightly. To make it easier for us to see this, a waveform expresses the level of energy or density. The x-axis of the waveform represents time, and the y-axis represents energy. Because this waveform information is analog, that is, a continuous value, it needs to be converted to digital so that a computer can understand it. Since an analog signal is expressed as a number with an infinite number and infinite precision, it is necessary to convert it into a number with a limited number and a limited range. At this time, the number of numbers to be extracted and used per unit time is called sampling, and the number of numbers to be expressed within a range is called quantization. The red dots you see in the picture is the result of sampling and quantization of the blue sine wave. If you connect these red dots with a straight line, you can roughly express the blue signal. But in this process, the detailed parts differ from the original signal, that is, distortion occurs. This distortion occurs where the values of both the time and energy axes differ from the original signal. Let me briefly summarize what I have explained so far. Sound is the vibration of air, and in order to input an analog signal into a computer, it needs to be converted to a digital signal. The necessary processes at this time are sampling and quantization, and signal distortion may occur during this process. In the next chapter, I would like to continue the story with the following topics. I will explain waveform, amplitude, and frequency, how to read a waveform, how to express amplitude as a finite number of numbers, and how to sample while avoiding distortion. Thank you.